All right, Math 5130, statistics for healthcare professionals. All right, so in the previous videos, if you look on the right, doing a little bit of split screen here, some of the things that we've covered in the previous video, we really reviewed it. Don't think I've really got into what I would call teaching it because you're expected to have a statistics class before taking this. So we've kind of reviewed histograms, box plots, measures of center, and measures of spread. So let's see how we can create these using StatCrunch. So what I want to do is I want to find this data set that's titled Arsenic in Rice. Sounds wonderful, huh? So if we go to data sets from your textbook, open up the data sets and come down to data set number 23, Arsenic in Rice. And so let's see what we have here. It looks like that we have some measurement of arsenic, 1.5, 3.7, 4.9 in Arkansas, 5.8 in Texas. So we have two variables here. We have the state in which the measurement was collected, and then we have the value of the arsenic. Now, you'll notice if you think back to video 1 or video 2, I told you, and I even demonstrated that when we have a data set that's in a form that is ready to analyze, when we read left to right, that information on that particular line, each particular line represents a particular subject. Well, we've got a problem here, don't we? Because when I read over from 1, I see a measure 1.5 that came from California, a measure 4.8 that came from Arkansas, and 5.6 that came from Texas. That's not what I need. I need to read left to right and have the arsenic measure, and then I need to have the other variable, which is the state in which this was actually collected. So it turns out it's really easy to do. If we go to data and come down to arrange and go to stack, it'll allow us to choose all the data. So I'm going to select all 3. And then I'm going to ID column. I don't want that, that's optional. Store labels in, I'm just going to call this state. And store values in, I'll just call this arsenic. All right, so I'm going to open this in a new data table, and I'm going to hit compute. Now I have my data set in a correct form. Remember, again, circling back to what I taught you in I forget, it was video 1 or 2, when we read left to right, we have information on one particular subject. In this situation, our case, or I should say our subject, is actually a case. This would be the 4th arsenic measure that was taken in California, and the measure was 4.5. Everything on this line pertains to that particular measurement. Down here, measurement 44 was taken in Arkansas. The value is 6.9. Okay, so what I want to accomplish over here really just focuses on the quantitative value. So I'm just really focused on arsenic right now. So first thing I want to do is create a histogram and look at the distribution shape. Well, it turns out that's really simple. Just choose histogram, choose arsenic. You can do some stuff here if you like. You can get a marker for the mean and the median. I really don't care about that when I'm creating a histogram. So I just compute, and remember when I compute this, I'm thinking classifying. Do I have positively skewed, negatively skewed, or bell-shaped and symmetric? I think this is bell-shaped and symmetric, and it is reasonable for me to conclude that this sample data came from a population distribution that is normally distributed. That's one of those things that is so important for me to be able to communicate to you, and you learn that when we get sample data, right here, it looks like we have about, well, 71 cases. We'll assume that this is collected randomly, and we're stating the shape of the distribution of the sample, but we're making a further statement whether or not we think that this data came from a distribution, a population distribution that is normally distributed. All right, so let's come over here. We would say bell-shaped and symmetric, reasonable to assume that our sample data came from a population that is normally distributed. Alrighty, let's create a histogram, or I'm sorry, a box plot to see if there's any outliers. So go to Graph, come to Box Plot. We want to use fences to identify outliers. Well, we should choose the variable, right? And draw boxes horizontally, whatever. If you want to draw it horizontally, you can. I usually create them vertically, but and I can demonstrate the difference. Let's compute. There are outliers. Right there we have an outlier, row 71. We have an arsenic level of 11, which is exceptionally high. And down here we have an outlier that is from row 1, arsenic 1.5. So we have two outliers, one unusually high, one unusually low. Now if I wanted to draw this horizontally, it's easy to do. Just click the horizontal box and it's drawn horizontally. So really there's no right or wrong, whichever you like. So let's just go back to the vertical. So we can say there are two outliers. Oh, shoot, that's kind of hard. 1.5 and 11, is that right? Yeah. All right, measures of center. Let's do it. So we go to Stat, we go to Summary Stat, we go to Column, choose the variable, and then come down and choose the things that we need. So I want the mean, I want the variance, I want the standard deviation, I want the median, I want the range, I want the min, I want the max, I want Q1, I want Q3. And I didn't really ask for IQR, but I'm going to get that. And we get all that stuff. So the mean is 6.72. I usually round to two places. The median is 6.8. I would want to be consistent, so 6.80. The range is 9.50. Standard deviation is 1.60. The variance is 2.55. The 5-number summary, the minimum is 6.8. Q1 is 5.6. Got sloppy there. Median, as we saw before, 6.80. Q3 is 7.60. And the maximum is 11.00. IQR, I'll just go ahead and put this in, is 2.00. All right, it's as easy as that. No fancy formulas, just using statistical software package to find these values. In the next video, what I'll do is I will teach you how to do these calculations in R. All right, take care.